Hi, folks. We're going to take a look at page 446, number 73. All right, so let's read the question. It says the Confederation Bridge joins New Brunswick and PI. So here it says, from a boat on the strait, the angle of elevation to the highest point on the bridge is 26.6, and then when the boat is 100 meters closer, the angle of elevation is 71.7, and they want the height of the bridge. Okay, so you have to be thinking that you've got some river that you're riding on, and then somewhere up here is the highest point to the bridge. So I'm not going to try to draw a realistic diagram, okay, but I'll just draw the water here, and I'll let this represent the highest point on the bridge. So at a particular location, you look up, angle of elevation, remember, is from the horizontal upwards. So this here is 26.6. And then 100 meters closer, so somewhere else here, you look up again towards the top of the bridge, and this is 71.7 degrees. And this distance between the two viewpoints is 100 meters. All right. Now, what we're going to assume is that we're measuring the height perpendicularly to the water. So unless it's specified otherwise, we're going to assume the height is above the water. Okay, so there's a few ways we can solve this. You can use just right-angle trigonometry, but that would take quite a few steps. You'd have to solve a system of equations. This is much easier to solve using non-right triangles. So I'm going to work with this triangle here to get a side length that's going to then allow me to use a right triangle to determine the height of the tower there. All right, now, I actually have some choice, because what I can do is from this triangle here, I can determine this side length and then use the right angle triangle at 71.7, or I could determine this length here and use the right triangle at 26.6 to eventually find the height. Okay, so I'll work with this one, doesn't really matter. Okay, so I see that I'm looking for this side here, and I have its opposite angle. Remember, you always ask yourself, do I have an angle opposite side pair? In which case you would use the sine law. If you don't, use the cosine law. Well, I know that this is 100 degrees. I don't know its opposite angle, but I can find it. Okay, because these two angles are supplementary. So let's calculate that one there. So 180 minus 71.7 is 108.3. All right, and now that we have these two angles, we can calculate the one up there. So 180 minus 108.3 minus 26.6 is equal to 45.1. So this angle here is 45.1. So clearly my diagram was not very accurate, but that's okay. We're just using it as a guide. Okay, so let's now find this value x. So remember, the sine law has two versions: the versions with the sine lengths in the side lengths in the numerator, or the ones with the angles in the numerator. Since I'm looking for a side length, I'm going to choose to put that in the numerator. So x over sine of its opposite angle, which is 26.6, okay, is equal to, and now I'm going to use this ratio, 100 divided by sine of its opposite angle, which is 45.1. Okay, and now this is very easy to solve because I'm just going to multiply that to the other side. Okay, so here we've got 100 times sine of 26.6. Okay, and then divided by sine of 45.1, and that's 63.21. All right, but now that I have this side length here, I can now work with this right triangle. So I'm looking for the opposite side to the angle, and I know the hypotenuse, so I'm going to use sine. So I have sine of 71.7 is equal to the opposite side, which is the one I'm looking for, h, divided by the hypotenuse, which is the one I just found, 63.21. Okay, so h, I'm just going to multiply that to the other side. Now I already have this on my calculator. This is why when you're doing these problems, don't erase what you have in your calculator. It might be useful in the next step. So I'm just going to multiply this by sine of 71.7, and there we go, 60 meters exactly, or almost exactly. All right. So let's just do a recap. Step number one is, of course, getting the correct diagram. Okay, realizing that you're looking up at an object from one point, and then you're moving forward and looking at it from another viewpoint, and that created this these two triangles. From there, I realized that I could use the non-right triangle to determine a side length in the right triangle, which contained the height that I was looking for. Okay, that's it for this one.